Hello viewers, and welcome back to my channel. In this video we are still on a mathematical method, and then in the previous video we talked about discrete least square approximation. Discrete least square approximation method, and this particular video will be talking about the continuous least square approximation, and this one deals with functions. Okay, while the other one deals with discrete, means like they will give you a particular point, you'll be given a particular point, then you will now use your least square method of approximation to get to fit in the curve. Okay, so but this particular video we're talking about when a function is given. So in the question they might give you a function or they might give you points. So if they give you points, use the previous one. If they give you function, you are going to use this particular one. Okay, so watch the video to the end for you to understand this. Now before we continue, my name is Kingsmatics, also known as Master Talker, and I have a full video on any topic at all you need in maths, physics, and calculation in chemistry. So if you come across any of our video and then there is any topic you find very difficult, just drop the name of the video, the name of the topic at the comment section, and I'll be sending you a link that will teach you that course from the basic, that's from the foundation to the advanced level. Okay, or just go straight to our playlist side of our YouTube videos to get the topic yourself. Okay, so now to do this I have to do a little recall on the last video where we talked about discrete least square method. Now for discrete least square method, we have that normally it doesn't change. That one is sorry, 1 minute. For discrete we have that where is it? So we talked about discrete for first order and second order. Okay, that's what we talked about for first order and second order. Now in discrete, remember that the first thing you look out for is your residue. Okay, in fact in anything least square method, the first thing you look out for is your residue, because we are here to reduce. Okay, so the residue S for discrete is equal to what? Is equal to your yi minus your capital letter yi, okay, then all raised to power 2. Okay, sorry, I forgot the summation. Sorry, there is a summation. S is equal to the summation as I start from 0 to n of this. Okay, so and then the normal way now, the next thing to do is to put in your y. Don't forget your y. Sorry, your y, this yi is just a function of y. Okay, it's just a function of x rather. Your y is a function of x, but okay, your y is a function of x. Your y is a function of x. Now, but in this case, in discrete method, you'll be given a point x and y. You'll be given a point x, I, and yi. So that's the difference between discrete and the function, okay, or our continuous. So you'll be given a point, so no need to say that your yi is a function of this. So you'll be given a point xi and yi. So this one remains here. So the main thing to note is this. So your yi, your capital letter yi, is equal to what? Your a0 plus what? a1xi plus what? a2xi plus a3xi. There should be cube here and there will be squared here, then plus dot dot dot. It continues that way. You understand? So like I said before, your xi and yi will be given. Don't forget that your I start from 0, 1, 2, 3 like that. Okay, it will be given. So that is that for that. And then to solve this like I did before is very easy. The first thing we do is to find the partial derivative. So partial x over partial a naught. Okay, now let us put back our distance. So we are going to have our yi. I'm not supposed to be doing this. Then you now put all this. So if it is first order, or polynomial of degree 1 rather, if it is polynomial of degree 1, we are stopping at this degree 1. If it is degree 2, we are including this degree 3, like that. So you can go and watch the video and then to understand it better. Okay, so that is not what I want to teach in this particular video. So in this particular video, we are going to be talking about for continuous variable. So watch the video to understand. Watch the other one to understand perfectly. But they are the same thing. Just the difference here is that in discrete we are making use of a point, while in continuous we are making use of a function. Okay, so that's the difference between the both of them. So let us go into that. We are going to be talking about continuous least square approximation of degree 1 and degree 2. So let's first of all talk about degree 1. For degree 1, polynomial of degree 1. For polynomial of degree 1, we are going to be having that our you know that normally your y, your capital letter Y will now be what? Your capital letter Y will be a0 plus a1x plus a2x squared plus dot dot dot, continue like that. So but since we are talking about degree 1, it's going to be ending here. It's going to be ending here. So because degree 1 means that the highest power of x is going to be 1. Okay, so now the difference between the continuous and the discrete is that for discrete your residue is given as summation. The difference is just this summation of I starting from 0 to n of your yi minus capital letter yi all square. Remember what your yi is. This is your yi. In that one, in this kit you'll be putting I in all this one, but in continuous we are not putting any I. So the difference is that the residue here is s is equal to, instead of using summation, we use integration. So the integral from a to b, okay, the integral from a to b, yeah, the integral from a to b of the same thing, of the same y minus no longer yi but y minus capital letter Y all squared the x. Okay, so that is all the difference between the two of them. This I shows that they will be giving you different points, you understand. But here we are not talking about points, we are talking about functions. So now remember that your y is always a function of x. Your y is a function of x. So for first degree, I'm going to have that my s will now be equal to, in fact, if you don't want to use this, anyone can come first. This can come first, this one can come first. S summation of integral from a to b of, you can take the capital letter y first minus small letter y, you get the same answer. Okay, anyone you like, you will get the same answer. So let me use this one. So I'm going to have the integral from a, the boundary they will give you from a to b of let me change this to a function of x, but you can use y, it does not mean anything. So minus, so for first order or first degree or degree 1, we are going to be putting this. So I'm going to have a0 plus a1x like this. So I will now close and put my dx. Now, so let us expand and then do the needful. So let's expand. So so don't forget there is squared, so they should be squared here. Okay, so now, so our x will now be equal to the integral from a to b of f of x minus, this time this I'm going to have a0 minus a1x, okay, all squared the x. Now don't forget, the next thing to do is to minimize, and we minimize by getting the partial derivative of x the same way you do in the other one. So the difference is just that the other one is discrete, that is numbers, while this one is function. That's all the difference. So partial x partial a0, which will give us if I differentiate this, I'm going to have minus and the differentiation of everything will now be 2 into everybody. Remember that I told that if you have 2 minus x all squared and you want to differentiate, this is chain rule. You're going to differentiate the bracket before you differentiate everything. So differentiation of the bracket, differentiation of minus x will give you minus 1, multiplied by differentiating something that has raised power 2 will give you 2 into that same thing repeated, raised power 2 minus 1 to give you 1. Because something raised power, this differentiation say multiply by the power, remove 1 from the power. So the method of function of a function means differentiate the bracket, multiply by differentiation of everything. So that's what we are going to do here. If I differentiate this bracket with respect to a0, there is no a0 here, this is 0. This a0 here, the coefficient is minus 1, so that is the minus you're having here. So this particular one, there is no a0, so it's 0. So the differentiation of something that has raised to power 2 is multiplied by that 2, then repeat this thing and remove 1 from this. Okay, so repeating this, let me first of all put my integral sign. So I'm going to have the integral from a to b of f of x minus a0 minus a1 x all squared. Sorry, there's no longer squared because it's multiplied by the power and remove 1 from the power. Okay, so there's no squared now, so I'm going to have the x is equal to 0. Don't forget that the residue of each of them is going to be 0. Now the partial s over partial a naught must be equal to partial s over partial a1, which will be equal to 0. So we're going to get this one equal to 0 and get this one equal to 0. These are the two equations we are looking for. Then if you evaluate the two equations and then you solve simultaneously, you will now get your a naught and a1. You understand? If you get your a naught and a1, then you now come back to this point and substitute it, and that becomes your answer. So the main point here is just for us to get our a naught and a1, then we are good to go. So let us continue. So now, I'm trying to scroll down. This is my mouse. So from here now, if we divide both sides by -2, so this -2 is gone, so I'm left with the integral from a to b of f of x minus a naught minus 1x, okay, all the x is equal to 0. So I can share the integration for them. So I'm having the integral from a to b of f of x, which is my y, don't forget the x, okay, minus the integral from a to b of a, the x, a naught the x, minus, I can bring out a1, the integral of x dx, okay, is equal to 0. So I'll collect like terms. All the 8 should be on one side, and this one that does not have 8 should be on the other side. So if this one moves to the other side, I'm going to have the integral from a to b of a naught dx, okay, minus a1, the integral from a to b, don't forget, from a to b of x dx will now be equal to what? The integral from a to b of f of x dx. Okay, this is my equation 1 that I'm looking for. Okay, so now for equation 2, I'm going to be having so for equation 2, I'm going to be having that ds, the a1 will now be 0. So I'm going to have that partial s, partial a1, partial a1. So partial a1 will now be equal to, so if I differentiate with respect to a1, I'm going to have differentiating, remember that our s is equal to f of s, the integral from a to b of f of s minus a naught minus a1x dx, right? Let's check again. Okay, all squared before the s. So if I differentiate the inside here with respect to a1, so you see that differentiation of a1s will give you x minus x. So the minus should be at the back here. So this 2 is going to multiply like before. I'm going to have minus 2 here. Then the integral of a to b. That x I got, because our integration is a function of x, it will not be at the back. So it's going to be inside there. X, then repeat everything here, which is f of x minus a naught minus a1x, okay, then dx. I will not put squared here because you multiply by the power, then remove 1 from the power. So this is equal to 0. So if I divide everybody by -2, this -2 will be out. I'll be having the integral from a to b of x into f of x minus a naught minus a1x, okay, then the x is equal to 0. So if I open the bracket, multiply by integral with x, I'm going to have the integral of a from a to b of x, a function of x dx, okay, then minus the integral from a to b. Okay, let me put a naught, okay, so I'm going to have a naught times this. A naught is a constant, so it will come outside. A naught, the integral of a to b of our x dx. So this one times this one, I'm going to have minus a1, the integral from a to b of x squared dx is equal to 0. Okay, so now the next thing to do is simply to collect like terms. Anybody that does not have a should go to the other side. So all the people with a go to the other side. I'm going to have my a naught the integral from a to b x dx minus a1 the integral from a to b x squared dx is equal to this one that is remaining here now, the integral. Sorry, this should be plus because everybody is moving to the other side. Sorry, this should be plus. Sorry, because this is minus moving here to be plus, this is minus again moving to this side to be plus, so it should be plus and not minus. Please take note of that. So I'm having the integral from a, I'm having the integral from a to b of x f of x dx. Okay, so this is my equation 2. So if I now evaluate, if I find the value of this and substitute my boundaries, you see that this is going to be a constant. If I evaluate this and put my boundary a constant, so I will be left with a0 and a1, you understand, with their constants as my equation 2, the other one as my equation 1. So if you solve that equation 1 and 2 simultaneously, you are going to be getting your a0 and a1 to substitute in your equation, which is y is equal to a0 plus what, a1x. Okay, so which is the main thing we are required to do in this case. So let's now talk about degree 2. If we talk about degree 2, I will now show you the easiest way to get all this, things. They are not, you don't need to start deriving them. The easiest way to get all these things, you don't need to start deriving them. Okay, so let's go to the next page. So for degree 2, we should have that our y, the capital letter y, is going to be what, a0 plus what, a1x plus what, a2x squared. So I'm stopping here because it is degree 2. So our residue s will now be equal to, if it is discrete, I'll be having summation, don't forget, but we are not using discrete here, we are using a function. So y is equal to a function of x. So this is continuous, we are not using that, so we are going to be using integration. So the integral from a to b, the boundary you'll be given of your what, y minus what, capital letter y. Okay, or let me use let me change it this time around. Let me use the big one minus the small one, so that you see that the same answer is what you are going to be getting. Capital letter y minus small letter y, then all squared dx. Okay, so now let me substitute everybody. So my x will now be equal to the integral from a to b of, so everything here is my capital letter y, which is a0 plus what, a1x plus what, a2x squared, then minus my y is a function of x that will be given, all squared dx. Okay, so the next thing to do is what, to get each of their derivative. So partial this must be equal to partial s partial a1, which must be equal to what, partial s over what, partial a2, and all of them must be equal to 0. So that is just the simple logic, then you are good to go. So let us get the first one. So to get our partial s over partial a0, it will now be equal to, so differentiate everything here with respect to a0. So if I differentiate this here, I'm going to get 1. So the 2 up, these two here will multiply again. So I'm going to have 2 the integral of a to b of, the integral from a to b of a0 plus a1x plus a2x squared minus f of x. So I will remove 1 from here, so the squared here will no longer be there. The x must be equal to what, 0. So what do we now do? So from here we are going to be having divide everybody by 2, so that these 2 will be out. If I divide everybody by 2, I'm going to be having that my integral, the integral of from a to b of your a0 plus your a1x plus what, a2x squared minus f of x, all bracket dx is equal to 0. So share the integral for everybody. So I'm going to have the integral from a to b of a0 plus what, the integral, a1, the integral from a to b of x dx plus a2, the integral of s squared dx minus the integral of f of x dx is equal to 0. So if you don't have a, move to the other side. I'm going to have the integral from a to b of a0 plus a1, the integral from a to b of x dx plus a2, the integral of x squared from a to b dx will now be equal to a to b. Please don't forget the a to b, a to b, a to b. So will now be equal to the integral from a to b of f of x dx. Okay, so now the next thing to do is to differentiate with respect to a1. So I'm not going to do that differentiation. Try it and then write the answer. I'll just show you how to get it. It is easier. It is very, very easy. So because we are differentiating, we are going to be having x. So the x is going to multiply just all these things here. You are done. Okay, so the next one should be s is multiplying everything here to get the next one. So s times this, I'm going to have a naught will now come outside, the integral from a to b of x dx. Sorry, I forgot the x here. Okay, minus, plus a1 outside, the integral of ab. So I'm going to have here is x squared dx plus a2, the integral from a to b. Here will now be s cubed dx. Will now be equal to what? The integral from a to b of x f of x dx. Okay, so now the third one, that will now be equation 2. Okay, so don't forget that this one is my equation 1 and this one will now be my equation 2. So for equation 3, I'm going to have multiply by x again for equation 2, because if you differentiate here, you're going to be having s squared. So that s squared is multiplying this side, or you say x will multiply this side. You understand? So my equation 3 will now be a naught, the integral from a to b of x squared dx plus a1, the integral from a to b of s cubed dx plus a2, the integral from a to b of x raised to the power 4 dx is equal to the integral from a to b of x squared f of x dx. You understand? So, and that should be your equation 3, and then you are good to go. So if you now evaluate all this integral, you will not get, I'm putting the boundary, you will not get number. I'm putting all this number, you are going to be having simultaneous equation that has 3 unknowns and 3 equations. So if you just solve it simultaneously, you will get your answer as simple as that. So we're going to be taking maybe one question. So just one question will be enough. So let's go to the next page. Okay, so the question we're going to be solving here says let's just get one question to solve. Okay, so the question said example okay, example, and this example said that construct a least square quadratic approximation. Okay, quadratic approximation for, you see that instead of giving us points now, they will give us y is equal to the square root of x. You see that? So they've given you a function over an interval. They give us interval from 0 to 1. Okay, then the next thing they say, we should now compare your results with the exact solution. Okay, and sketch the graph. Okay, solution. The same thing now. We have gotten that our y, they've given us that our y is equal to what? We know that is a function of x, which they have given us as the square root of x. Very simple. And then we know that our capital Y is equal, since they say quadratic means second degree 2. That's the meaning of quadratic. So I'm going to be having a naught plus what? a1x plus what? a2x squared. That is for quadratic. So now what do we do now? The next thing to do is to get our residue. Our residue s will now be equal to what? The integral from a to b of, I want to have the capital letter Y first before the small letter y. So all squared dx. I thought that they are the same thing. They must give us the same answer. So our a and b are these boundaries, 0 and 1. So my residue s will now be equal to the integral from 0 to 1 of my y is our a naught plus what, a1x plus what, a2x squared, okay, then minus our y they gave us is the square root of x, okay, then the x, don't forget all squared. So now the next thing to do is to get the partial derivative. So you're going to have that the partial s over partial a naught must be equal to partial s over partial a1 must be equal to partial s over what, partial a2, and it must be equal to 0. So once you get the first one, to get the other ones will now be very easy for you, okay. Once you can get the first one, to get the rest will now be very easy. So I'm going to have that for us to get the first one, which is partial s over partial a naught, is going to be, differentiate a naught, you're going to have 1. So the 2 to come to the back, I'm going to have 2 the integral from 0 to 1 of our a naught plus a1x plus a2x squared minus the square root of x, okay. The squared here will go, the x equal to 0. You know the reason the squared went out, so multiply by the power and remove 1 from the power. So now divide both side by 2. So I'll be having the integral from 0 to 1 of a naught plus a1x plus a2x squared, then minus the square root of x, all the x will now be equal to 0. So share the integration for them. If you share the integration for them, you're going to be having the integral from 0 to 1 of your a naught plus a1 the integral from 0 to 1 of your s dx, sorry, there should be the x here, okay, then plus a2 the integral from 0 to 1 of your x squared dx. Then don't forget that this one will move to the other side. It will now be equal to the integral from 0 to 1 of your, let me call it s raised power 1 over 2. I hope you know that s raised power 1 over 2 is the same thing as the square root of x. So now if we integrate this, you're going to be having, look at that, if you integrate this, you're going to be having the integral, if you integrate this with respect to x, it's just to bring in x now. You know, normal integration, you bring in x, so it's going to be a naught in bracket of x. Then now put the boundary. The boundary should be from 0 to 1, okay, from 0 to 1 like this, okay. Then plus the next one is you put your a1. The integration of this will give us x squared over 2. Add 1 to the power, divide by the new power. So you're going to add your from 0 to 1, from 0 to 1. Okay, so next one is plus a2. This one will now be 1 over 3. It will now be s raised power 3 over 3. Okay, don't forget your 0 to 1 is equal to, if I add 1 to this power, 1 over 2 plus 1 to give us 3 over 2. So it's going to be 3 over 2. So if I divide by the new power, it's going to be 2x raised power 3 over 2 over 3. Okay, so divide by, add 1 to the power, divide by the new power. So you're going to be having 2x raised to power 3 over 2 all over what? All over 3. So you're going to be having, don't forget your boundary from 0 to 1. So now the next thing to do is if you substitute the above minus below. So 1 minus 0 is 1. So 1 times this, I'm having a naught here, okay, plus you can decide to bring the 1 over 2 outside. If I bring the a1 over 2 is a constant, then you do the substitution again, above minus below. 1 squared is 1 and 0 squared is 0. 1 minus 0 is 1 again. So 1 times this, I'm having just a 1 over 2, okay. So plus, you can bring out this one again, a2 over 3. Then you are left with s raised power 3. So s raised power 3, you now have 1 raised power 3 minus 0 raised power 3, which is still 1 again. So you still have this. So is equal to the same thing here. If you have you bring out your 2 over 3, then if you put 1 raised power 2 over 3 is 1 minus 0 is still 1. So I have this. So this is my equation 1. You understand? So this is my equation 1. So for us to get our equation 2, you come back to this place. I don't need to start differentiating again. All I need to do is this last answer I got here, this last answer here, I will just multiply it by x. This answer here, just multiply it by x to get your next. Okay, so but if it is theory, you have to show it one by one. Okay, you have to show it one by one. So let me just show it. Let's assume it's theory. So let's just show it. So the next thing we're going to get is partial s over what? Partial a1. So which is, if you integrate, sorry, if you differentiate a1, you're going to be having s. So it's going to be the 2 coming here. It's going to be 2 the integral of x here, repeating all these things, then raised to power, then without. So this is how it's going to look like. So I'm going to have my 2 outside, the integral from 0 to 1, sorry, from 0 to 1 of x here, in bracket of a0 plus a1x plus a2x squared, then dx. Okay, so divide both sides by 2. This 2 is gone. I'll be having the integral from 0 to 1 of x into a0 plus a1x plus a2x squared. Okay, so I'm going to have dx. So don't forget, it must be equal to 0. So it's equal to 0. So the next thing to do is to share the integration and multiply out again. Sorry, I forgot minus. There should be minus root x. So hey, it should be minus root x. Don't forget that, please. So if you multiply out, you're going to be having the integral from 0. In fact, I'm going to have a0 first. So I'm going to have a0, the integral from 0 to 1 of x dx. That is everything here multiplied by a0. So a0 is a constant, it can come outside. I'm left with this one, dx. Okay, so everything here multiplied by this and the x, I'm going to have plus a1, that is a constant, come outside, the integral of x squared dx from 0 to 1. So the squared is the x here times x here to give you x squared. So plus the next one is a2, the integral from 0 to 1 of x to the power 3 dx. Okay, then minus the integral from 0 to 1 of x, the root of x dx. So I'm multiplying x by the square root of x, then with my dx. And don't forget that this is x to the power 1 multiplied by x to the power half. So according to indices, you know that this one is x to the power half. According to indices, you can add the power if the base are the same. So I'm going to have x to the power 3 over 2. Okay, so everything here will give me x to the power 3 over 2, so equal to 0. So let this one that does not have a move to the other side. I'm going to have that a0, the integral from 0 to 1 of x dx, plus a1, the integral from 0 to 1 of x squared dx, plus a2, the integral from 0 to 1 of x3 dx will now be equal to the integral from 0 to 1. I've gotten everything here to be x raised to power 3 over 2 dx. But if it is not something you can multiply out, then that means you are going to use integration by parts here. If it cannot multiply out the way I multiply this one, then you apply integration by parts. So now, so to get this, I'm going to have a0. If you put 1 again, if you integrate here, you are going to be having s squared over 2. That is add 1 to the power, divide by the new power. So you put from 0 to 1, okay, plus this is a1, add 1 to the power, divide by the new power. So you're going to be having s cubed over 3. Don't forget from 0 to 1, then plus a2. Here will now be s raised to power 4 over 4. So don't forget from 0 to 1 is equal to, here will be, if I add 1 to this, it's going to be 5 over 2. So it's going to be 5 over 2. So x divided by 5 over 2. So it's going to be 2x raised to power 3 over 2, then over 5. So don't forget your 0 to 1. So now if I put in, I can bring out the constant a0 over 2. If I put in 1 squared is 1, minus this is gone. So it's 1. So 1 times anything is same thing, so it's gone. So plus the same thing here, a1 over 3, okay, plus the same thing here, a2 over 4, then is equal to the same thing here, 2 over 5, 2 over 5. So this is my equation 2. Okay, so you can try to do equation 3 by yourself to know if you will get the answer. Okay, so try to do it, but I'm not going to do it. What I'll simply do is to multiply everything I've gotten here, multiply everything I have here by x to get equation 3. That's what we are going to do. Yes. everything here, multiply by x to get equation 3. As simple as that. But if it is theory, you have to show it that partial s over partial a3 will give us 0. You have to show it. So try to show it yourself. It will help you understand it better. You understand? Then you now check if you got exactly the same results as myself. So for me here, I'm going to have that my equation 3 will look like a naught. Okay, let me write with red pen. Wow, it's looking good. So a naught, so let me be seeing it. A naught, the integral of what? S squared dx, okay, plus a1, the integral of what? S cubed dx, okay, plus a2, the integral of s raised to the power 4 dx. Don't forget from 0 to 1, from 0 to 1, from 0 to 1. So will now be equal to the integral. If I multiply x by this, it will give you s raised to the power 5 over 2. So it's going to be s raised to the power 5 over 2 dx. So from 0 to 1. So you can pause the video and then solve your own and see if you get exactly the same result as myself. Okay, so now I'm going to be having my, in fact, for this place you can find the LCM of the denominator, multiply through, so that you will not be having fraction. If you want to solve the simultaneous equation, you will not be having fraction. So I'm going to be having so to solve this, I'm going to having a naught, add 1 to the power, divide by the new power to have s raised to the power 3 over 3. Don't forget your 1 and 0 plus a1. So I'm going to be having s raised to the power 4 over 4. Don't forget your 0 and 1 plus a2. I'm going to have s raised to the power 5 over 5. Don't forget your 0 and 1 is equal to, here will now be s raised to the power 7 divided by 7 over 2, which is 2 s raised to the power 7 over 2 all over 7. So don't forget your 0 and 1. So if I do the same thing, I'm going to be having a naught over 3 plus a1 over 4 plus a2 over 5 is equal to what? 2 over 7, equation 3. So if you solve your equation 1, 2, 3 simultaneously, I don't have time to start solving it, so you need to learn how to solve simultaneous equation of 3 unknowns. If you don't know it, I have a full video on that. You can tell me to send you the video, I will send it for you. But before that, if you want to solve it by yourself, what you need to do is the first thing you need to do is to find the LCM of this denominator and multiply each of them by the LCM, so that you will no longer have denominator. Do it for the 3 equations so that it will not look easy for you to solve. You can use any method you like. You can use the elimination method, you can use substitution method, you can use your Cramer's rule, by matrix, anyone you like, but the easiest is by elimination method, or use your calculator and punch your calculator and get your answer. So the answer you are going to be getting is that a naught is equal to 6 over 35, 6 over 35, and then our a1 will now be equal to 48 over 35, and then our a2 will now be equal to minus 4 over 7. So that's what I got. Okay, so once you have this, your answer will now be that capital letter Y, which is equal to what? A naught plus what? A1x plus what? A2x squared. So you now come back and put it. You now see that your final answer, sorry, I think this has gotten to the end. Okay, so your final answer is simply 6 over 35 A naught plus 48 over 35 A1 plus minus, not plus again, but minus. Okay, so minus 4 over 7 x. Is it A1 I'm using instead of, sorry, why will I be repeating the A again after getting it? Sorry, this here should be x, and here should not be x squared. So here will not be x, and then here will not be x squared. So that is the result. So the next thing we are asked to do is to compare your answer with the real solution. Okay, so to compare the answer, we're going to do it in form of a table. Don't forget that the boundary, don't forget that my boundary is that x is an element of, and x is an element of 0 and 1. So my boundary is from 0 to 1. So I can have this is my x. I can start with 0. I can start with 0.0, 0.2, 0.4. You can choose anything. 0.6, 0.8, 1.0. Okay, so I'm going to be having my y of x. So y of x, don't forget my y is equal to what? My y is equal to what? F of x. No, okay, which they gave me as the root of x. So square root of 0 is 0. Square root of 0.2. This one is the real value. Your y is the real value. So square root of this will give you 0.4472 in 4 decimal place. The square root of 0.4 will give you 0.6325. The square root of this will give you 0.7746. The square root of this one will give you 0.8944. Square root of this is giving us 1. So but in the other one, our y of x, which is the answer we got, is for us to be substituting. We are going to be using this thing here now, right? Sorry, not here. So previous page. So we are going to be using this equation. So to get the first one, we are going to use this plus, you put your x. So if you do the math, look at the answers you are going to be getting. So just in each of the points, be putting all your x to get your y. You understand? It is not difficult. So if you are putting it, you are going to be getting, for the first one, that is 0, is giving us 0.1714. The next one is giving us 0.4228. The next one is giving us 0. You can punch your calculator to be sure. 85. So the next one is giving us 0.7885. So the next one is giving us 0.9028, and the last one is giving us 0.9714. You understand? So that's why I told you that in the former video that you will not get exactly the same value. It is an approximated value. That's what they call it, approximation. So the next thing to get is your error. You can get your error. Your error is the absolute value of any one you like. You can use y minus capital letter Y, or you say the absolute value of capital letter Y minus Y. So the absolute value will make it positive. We don't need negative. So 0 minus this, and then with absolute value will give you 0.1714. If you subtract the other one, you're going to get 0.0244. So you're going to be getting 0.0040. You're going to be getting 0.0139. You're going to get 0.0084, and then finally 0.0286. Okay, so that is the comparison you are asked to do, as simple as that. So the next thing we are going to do is to sketch. Don't mind my own. Here is my y and here is my x. So for my x, remember we chose this is the beginning 0. Let's say 0.2, 0.4, 0.6, 0.8, 1.0. So for y value, if you look at y value ranges from 0 to 1 again. So there is no number that is greater than 1 here. If you check, it ranges from 0 to 1. So we can use the same thing again. We can use the same thing we use the scale. You know that this is choosing of scale. You can choose anything you like. So this is 0.2 again. Let's say 0.4. Okay. 0.6, 0.8, 1.0. So when x is 0, my y is 0. So this is the first point. Sorry. Okay, yes, I want to plot the main. I want to plot this I want to plot the normal result before I plot. I'm plotting this. I'm plotting x against y. I will still plot x against y like this. This and this and this and this. So you just need to be putting it and then know how the curve will look like. Okay, so the first one is 0, 0. The next one is 0.2. When x is 0.2, my y is 0.4 something, so somewhere here. Okay. So when x is 0.4, my y is 0.6 something, so somewhere above, somewhere here. Okay, you know it's sketch now. When it is 0.6, it is 0.7 something, so let's say somewhere here. So when it is 0.8, it it is 0.8 something, 89 something, somewhere here. And when it is 1, it is 1, so somewhere here. So you just join, don't mind my own. So plot for the other one and tell me how it will look like. So that is that for that. So thank you very much for watching this video. Please always drop your comments and then subscribe if you are new to the channel, and then just if you have any question or any topic at all you find difficult in maths, physics, and calculation in chemistry, tell us in the comment section. I will drop you a link to a video that will teach it from basic to advanced level. May the peace of the Lord be with you. Bye bye.